"3D cinema is back. Bigger than ever. We'll tell you how it's done and why today's technology means it's here to stay." "3D projection, showing depth on a flat screen. It's a trick that takes advantage of the way humans see naturally, in stereo.
In order to see in 3 dimensions, you must start with having binocular vision, meaning that there must be input from both eyes.
Since eyes are set apart, the view from each eye is a little different.
They have to be off a little bit horizontally, a very slight misalignment, which allows you to see the exact same image slightly different in position.
To see how different these positions are, put a finger in front of your face and close one eye. Open it and close the other. The image appears to move because the angle of the view is changed. This is known as the horizontal disparity. To see in 3D, your brain needs to merge these two images.
You must be able to fuse that image. Now, once that image is perceived or comes through, it's transmitted through the optic nerves in each eye, and it goes back through the optic tract, and eventually they go to the cortex area, the occipital lobe, where the fusion process takes place.
Here, the brain fills in the missing information between the right and left images, adding depth. The process is called stereopsis.
It's the ability to see things in depth, in perspective, and ordered in space, sort of say that one thing is closer than the other, based on this ability to use both eyes together and to be able to view slightly horizontally separate, or we call them disparate images.
In a process known as stereoscopy, 3D filmmakers trick our brains into extracting the same depth information by projecting two slightly different views of the same movie onto a flat screen. Special filters separate the images so that our left eye sees only one view and the right eye sees the other.
So in order for a 3D display, either at the movies at home, to fool us, I just need to show a left picture and a right picture. So if I want to represent a face, all right, so here's what the face looks like from the left eye, and then I'm about as close to you, I can close this eye and see that your face has moved a little bit that way, so, and here's the right eye. And it's the same picture. Now, what the display needs to do is separate these two images so that this eye only sees the image that it needs to see and the other eye sees the image that needs to see. And we usually do that with glasses.
The glasses most commonly associated with 3D use color filters to isolate left and right views, one red lens, the other green or blue. But as early as the 1950s, the so-called golden era of 3D film, Polaroid glasses became more popular, mostly because they didn't interfere with the color of the film.
There are a lot of magazine articles, even major newspapers, perpetuating this myth that 3D in the 50s was the red-green glasses, bad quality. It's not true. The 3D of the early 50s that Hollywood produced was of the top quality Polaroid system. And the beautiful color 3D, vivid images, great stereo effects, really wonderful.
A look at golden era technology illustrates how 3D glasses are used to separate right and left images on the screen. Then, as now, movies were filmed using two cameras rigged closely together, like a pair of eyes. The film from both cameras was processed, resulting in two full-length features, one for the left eye, the other for the right.
When we talk of 3D, we're dealing with two films running simultaneously on two different projectors. We have filters in the pod glass which filters the different view paths of each film.
The filters are polarized, one vertically, the other horizontally. Viewed without glasses, the images on the screen appear blurry because they are overlaid and both eyes see both images at the same time. But when viewed through glasses,
the left eye glasses sees only things coming from the left projector, and the right eye glasses sees things coming only from the right projector.
That's because the left and right lenses in the glasses match the left and right filters in the projectors. Each lens passes only the light from its matching filter and blocks the other light, isolating the left and right images on the screen. This gives the brain the same type of binocular cues it would receive if the viewer were actually standing in the scene, and the result is 3D. This early system worked well, but it wasn't easy.
The machines have to be in perfect sync. The motors have to run at the exact same speed. Each frame of the print has to be precise. If it's off by one frame, the 3D doesn't work and people get headaches. If it's in sync, it's beautiful.
It went out of sync. It went out of frame.
Beautiful, but commercially impractical. The golden era of 3D ended almost as quickly as it began, before the mid-50s.
It was such a cumbersome technique, both for the projectionists and the audiences didn't care for wearing the glasses. The novelty wore off.
The novelty is now back, and so are the glasses, but the projection technology has changed dramatically. Find out why that change has Hollywood betting that this time, 3D is back for good.
In 3D.